Hi, everybody. So I think let's start. Welcome. It's a pleasure to see some known names here in participants, as well as a lot of new names, which is great. So let me start from some quick formal introduction, who we are and why we're talking about this. And then we'll do a lot of practice today. We'll start from very simple warm-up problem, and then we'll talk about a little bit more advanced one. So my name is Borys. I'm a co-founder and CEO of Engenious. I enjoy and love teaching. A lot of people here have seen me as an instructor on Code Fitness and BakeQA companies. That's our formal brands. We started Engenious on top of all those brands, and now we unite consulting services as well as educational services. I'm a developer myself. I used to be a Java developer, then I have a pretty big experience as an iOS developer at Tinder and other big brands. And as of today, I'm CEO of Engenious, and I enjoy conducting interviews myself. So I've conducted hundreds and hundreds of interviews. I love to ask about the coding challenges, since this is something I was good at back at the times when I studied and became a Java developer and iOS developer. So today we'll talk about some simple strategies, how to practice and how to succeed in those coding interviews, as well as we'll touch why this is needed in general. So I have some academic experience. I have 2 master's degrees from US and Ukraine. So I spent quite a lot of time solving different algorithms in my life. Okay, so this webinar is on behalf of Engenious University. This is something completely new. We ramped up our first bootcamp, online bootcamp. This is iOS test automation with XUI test course. Like a lot of people seen these cars offline back in days before COVID. And now finally we are fully live with online course. A lot of more courses are coming, but this one is our first under Engenious University itself. Okay, so agenda for today. We'll talk about general things like why coding challenges are still in the game, even though so many people hate it. What are the prerequisites, how to tackle the problem. We'll do 2 practical examples. One is like super simple, and another one is a little bit more complicated, and we'll also do different approaches for that problem. So I'll show you how to approach problem differently, and yeah, and then we'll just talk about how to practice those things. So like, I'm not 100% sure what is the background of all participants here today, but I'm pretty sure I've seen a lot of manual testers here. And from my experience, the majority of manual testers are willing to become STETs at some point of time. There's just a logical next step of career, even though it's not mandatory. So there are 2 branches for manual QA, right? You can go towards automation stuff, or you can go towards seniority in the manual branch. That's totally normal as well. But for those who would love to make an automation step, and basically they enjoy coding, they understand some basic principles of coding and programming in general. For those people, usually the biggest obstacle is coding challenge. They're just afraid of coding challenge, and they understand that this is required for the majority of automation vacancies out there in US. So this is something stopping them, literally stopping them from doing this big step. So and they think that that this is something like some not unique skill, but some skill that is easy to do if you're a coder and hard to do if you're a tester. And that's not true. Like, this is completely separate skill that needs separate practice. And like, I've seen a lot of senior engineers who fail coding challenge, even though they are coding for 20 years and they're doing great on their jobs, and they're doing very they write very good quality code, but still they do not practice coding challenge and they fail because this is a separate skill you have to practice. So if that doesn't really correlate that much, correlate with their daily job, why they're still in the game? Why companies still ask about the coding challenge? And the answer here is, so this is a pretty funny poll on the screen that shows that the majority of participants, obviously they prefer technical tests with practical coding questions, right? Because that's the closest thing to what you actually do on your day job. If the company will ask you some practical task, like if you're iOS developer, please create an iOS app. If you're backend developer, please create some API or infrastructure, etc., etc. That seems logical. Why would they add coding challenge on top of that? And the answer is that's just the way how big companies differentiate people who are willing to learn something new, who know how to think outside the box, and who can prove they can spend some time, practice those coding challenge, they can learn those things in order to get the job. That's number one. And secondly, that's useful. Even though if you're coding, you may think you are not using those algorithms, it just helps you to structure your mind and approach the real world problems with optimal and efficient solutions. So you're coding as regular, but you just do things properly, efficiently. You think about things that might cause problems in the future, etc., etc. So all those big tech giants, they're not stupid for sure, right? So they are asking those things for a reason. Okay, so what are the prerequisites to do some coding algorithms, right? To do some coding challenges. First of all, language does not matter at all. Like, at all, 0% importance. Like, doesn't matter. Like, it is even possible to solve coding challenges and algorithms without programming language. You can do pseudocode and it's still be as valid. It's just hard to prove you know how to solve it, right? It's hard for interviewers to run your code and to check if that's correct. So you usually have to know at least one programming language and use it. But it absolutely doesn't matter which one. Java, Swift, Go, Python, C++, C#, doesn't matter, you name it. So any language will be fine. Same with IDE. It's absolutely doesn't matter. Do you run your code in Xcode, in IDEA, in TextEdit, whatever. Today, I'll show you some coding in just online Swift playground that I found as a first link in Google, just so I don't need to open my Xcode, etc., etc. So it absolutely doesn't matter where and how and what language you write. So the fundamental concept here is idea how to solve the algorithm efficiently. That's it. You need to know fundamental concepts of programming. That's for sure. By fundamental concepts, I mean something that any YouTube tutorial course will give you the knowledge. This is basically variables, basic syntax, how to use data types and structures, at least some basic like arrays, dictionaries, text queues. That's like something you learn on the third week of programming, right? And there are some more advanced like heaps, trees, linked list, graphs. Also not extra hard. You at least need to know how to, what is this and how to deal with that. Flow control structures like if else, switches, etc. Functional and object-oriented programming will be a big plus. And you need to know how to debug because algorithms are pretty challenging. So you will definitely do some mistakes. You need to know how to debug those mistakes. So that's just fundamental concepts that like what doesn't matter which language you choose. If you go and learn this language, that's just first months of learning of any bootcamp, right? For in our iOS test, XE UI test bootcamp in Engenious University, we start from the module of fundamental concept of Swift, and obviously we show all those things for Swift purpose. But again, syntax is a little bit different for any language, but the ideas and concepts are identical. Okay, so before we start practice, let us do a little quick poll. Yes, thanks, Elena. You can see very quick one question poll. It will help us to understand your experience. So please choose what types of algorithms have you ever solved. And this is multiple selection. Should be multiple selection, right? So you can choose multiple answers. Let's spend a couple of minutes and wait for the answers. Meanwhile, is it possible to have a recording of the session? Absolutely, yes. We will share the recording with all of you. Okay, interesting distribution. Let's spend one more minute. Feel free to answer. It will help us to understand your experience. 71% worked with sorting. That's nice. Great. Okay, great to know. Okay, so our favorite six questions for any algorithm. I definitely see a couple of people here in participants that took our offline algorithms bootcamps, which was much more comprehensive, and it was a couple of weeks. So you remember for sure those questions, right? So we are starting usually from input and output. So first one is what should the data type of the answer that your function has to return? What should the, sorry for grammar error here. What is the input parameter? Then we are thinking about what data structures and methods associated with it will be used. Very important one. The next question is where you're going to store your temporary data if needed. Not all programs need it. Then we are trying to describe the model of our algorithm without using code. It can be pseudocode, it can be English, plain English, or it can be some diagram. And then we actually implement solution, and we do not forget about unit tests. So we'll get back to this slide while we're practicing. Okay, so the first question for practice is probably the most famous and simple problem, which is FizzBuzz, right? We always start from this. This is warm-up question. So the problem is very concise. We need to print integers 1 to m, but print fizz if an integer is divisible by 3, buzz if an integer is divisible by 5, and FizzBuzz if an integer is divisible by both 3 and 5. So, as I mentioned before, we're going to use online Swift compiler. Let's double check it works. So you can just click run here. and you need to refresh, right? Cool. Okay, so basically that's just similar to Xcode Playground, if you ever seen one. You don't need to create a project here or do anything. It just runs one by one, all the lines you have here. You can print any result you need, right? In our case, we just print hello world and we see the console without. That's it. So, and that's Swift 5.1. Here, compiler uses Swift 5.1. But again, it absolutely doesn't matter. We're talking about algorithms. We're talking about ideas in general. Which way we're going to do it doesn't matter. Okay, so let's get back to our 6 problems and let's get one by one. Output. What should the data type of your answer that your function has to return? The majority of algorithms return something, but in our case, in FizzBuzz problem, we are asked to print integers. That's not very usual. That's just warm-up question. So there is no output here, right? We need to print output. So I would say no output. What is the input parameter? That's very tricky one. A lot of algorithms do not state this transparently. So like, what should be the input here? And obviously, for those who have an experience with solving those questions, you can easily say that there is a variable here, n, that is unknown. So the algorithm should work for any n you provide. Obviously, that are bigger than 1, because the way it's stated here, from 1 to n. So we can do an assumption that n is bigger than 1. So the algorithm, our solution should work with any type of n. You can feed to the algorithm 2, n as a 2, and you can feed an algorithm n as 100, and both should work properly. So the input will be n. So I would write output, no output. Input, n, and I'll say bigger than 1. So the data type of n is integer, right? So I can say it's int. In Swift, integer is int. Now, what data structures and methods associated with it will be used? So let's think. We have to print integers from 1 to n, meaning that we need to work with every single number from 1 to n. We need to work with 1, we need to work with 2, we need to work with 3, blah, 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 blah. We need to work with that. There is obvious loop here, right? We don't know which n is. Is it 1? Is it 2? Is it 10? Is it 100? Is it 1 million? So it's absolutely needed to go with some loop through every single number. So we are not sure what data type will be used here, and do we need a data type here? But we need a for loop for sure, because the idea is obvious. Let's go with a for loop. Let's iterate with a for loop. It can be while loop as well, but for loop is more like the easiest one. With a for loop from 1 to n, check every single number, identify if it is divisible by 3 or 5. If it is divisible by 3, by 5, by 3 and 5, right? Great. So that's our, not a pseudocode, but that's just the our model of algorithm, right? Where are you going to store temp data? We don't need temp data here. We just need to print those numbers. So why would we store them? So we're ready to implement. Okay, in Swift, we can implement this function like this. So basically, we are writing a function, which is FizzBuzz. We have one input parameter. We identified it here. So it's n, right? So we can say n int. And do we need an output? No, we identified here that we don't need output. Let's write it. So, and we have a model here. Let's iterate with a for loop from 1 to n. So we start for some I, right, iterator. And we, in Swift, we can say in 1, 3 dots, n. And again, in Java, it will be a little bit different. We'll say here, like the syntax will be different. But the idea, the model is let's iterate from 1 to n and check every single number. Here is, we have an I, which is every single number from 1 to n. So we can check our I for whatever we need. We can say if I, and how to check if it's divisible by number, like that's just a mess here. The number is divisible by another number if a remainder of the division is 0. So 6 is divisible by 3 because 6 divided by 3 equals 2 and the remainder is 0. But 7 is not divisible by 3 because 7 divided by 3 is 2 and remainder is not 0, it's 1. 7 is not divisible by 3, right? So the number is divisible by 3 if the remainder, and in Swift, as in majority of languages, the remainder can be founded with percentage. And that's a very important operation in computer science. It's used a lot. The second algorithm, which is a little bit more advanced, will use this operation as well. So if I divided by 3 with remainder equals 0, the remainder is 0, right? Then what? We can substitute and print this. Then we can say same thing else. If the number is divisible by 5, then we say bus. Then we can do the same thing and say if, else if it's divisible by 3 and by 5, and there is some error here on purpose, we'll talk about this later, we say this bus. Otherwise, if none of those conditions are met, so we have some I that failed this condition, it's not divisible by 3, failed this condition, if it's not divisible by 5, and failed this condition, obviously it will, right? Because it's not on 3 and not on 5, then we have to just print the integer itself. So we just print I here. Let's check and see what's wrong here. This bus with n, let's do 15. And the online compiler is a little bit buggy. We need to refresh sometimes. Run, please. Okay. First of all, so yeah, sure. I divisible by 3, what? Equals 0, right? The condition itself is missing here. Okay, so what do we have here? 1, so n is 15, means 1, 2, then 3. 3 is divisible by 3, so we replace it with 3. 4, bus. Bus is divisible by 5, so we can replace it with bus. Then 6. 6 is divisible by 3, so we can replace it with fizz again. 7, 8, 9 is divisible by 3, so we replace it with fizz. 10 is divisible by 5, so we replace it with 5. 11, come on. Can I make it a little bit bigger? It just doesn't. Come on. Okay, I don't know what to do. Sorry. Will it work now? That's weird. Yeah, the compiler is just not really good. Let me find something that will show us the whole output. We need to see this output. Let me try this here. Swift online compiler. So that's just not a problem, right? We can use any compiler. There are plenty of those. For example, here, let's just print it here from here and put it here. So if it's good, okay, that's better. So we can see. So again, I just changed compiler ID because, as we mentioned on slide 4, ID and language does not matter at all. Okay, so 1, 2, blah, 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 blah. We have a problem here. 15 is divisible by 3 and by 5, but we replaced it with just fizz. Obviously, that's because we checked this first. So the condition when we check both 3 and 5 should be before the condition when we check only 3, because this condition will be always true if this is true. But this condition will not always be true when this is true. So obviously, we need to change those things and check the fizz bus first. Else, we can check 5 and 3. Doesn't matter. Here's so if else, if cool. So we just check for 3 and 5 first, then we check 5, then we check 3, or 3 and 5. It doesn't matter. Otherwise, we just print I. Now we have fizz bus, and this is correct. Again, that's a warm-up problem, very popular. As you can see, it's important to identify output, input, and then just do the model for yourself. It will be much easier to code later. Let's move on to the next one. And the next one is also famous, which is palindrome, but that's not a string palindrome, it's an integer palindrome. So given a natural number x, return true if x is palindrome integer. An integer is a palindrome when it reads the same backwards and forwards. For example, 121 is a palindrome because you can read from left to right 121 and from right to left 121. However, 123 is not a palindrome because 123 is 123 and 3 to 1 is 321, which is completely different number. So we will do 2 approaches here. First one, we'll treat this input. Sorry, let's start from our 6 problems and identify them. This. So let's print this buzz problem. And now let's print int palindrome problem. So what do we have here? What is output? what do they ask us to give as an output? So they ask return true if X is palindrome integer. So, and return false if the integer is not palindrome, which means that output will be bool, right? True or false. If it's palindrome, we return true. If it's not palindrome, we return false. The second one is input. Input is obviously the natural number, X. So X as an integer. Now, what we're going to do. The first approach will be more simple. We'll try to convert, to cast the integer to string and work with a string. That's more classic way of palindrome, right? And then we'll do a second approach if the interviewer will ask you, what if you cannot use casting to string? That's absolutely normal in an interview when they ask those questions. So first approach, let's convert X to string. Sorry. Let's convert this to string, and then let's do this. Let's say we have some string, hello, OLLEH. So that's a palindrome, right? Or sorry, let's just use numbers since that's a number. 1, 2, 3, 4, 3, 2, 1. We got the string. So what can we do with string? We can do some for loop or something, and we can check if that's a palindrome in the direct way. So we can check if the first symbol equals to the last one, if the second symbol equals to the one to last, if the third one equals to third to last, etc., etc. So to do that, compare first with last, second with second to last, etc. Let's implement. So func is palindrome with X as an integer. We return bool as we stated here. So output is bool. We are going to do the next. So let's do string X. And that's very easy to do in Swift. You can say it's string from X. So the string has an initializer from integer, so you can do that, string X. Now, let's create an array of character. So let's split 1, 2, 3, 4, 3 to 1 to an array when every single element is a digit. So 1, 2, 3, 4, 3, 2, 1. Because then this way we'll be able to get those digits and compare them. Otherwise, it's really not clear how to get the concrete digit. So chars will be array from string X. Swift is very convenient. Now, let's iterate through this array. So in Swift, you can do the thing when you can iterate in array.enumerated, basically every single every single language has something similar. Well, in Java, you can just specify you want I, and then as an iterator, and X as a char, whatever, right? So in Swift, you do chars enumerated, which gives you a tuple, and the tuple contains the index and the element itself. Now, what are we going to compare? So left char is basically our char, right? That goes from left to right. The right char is, we have to get this one. We can get this in array of chars with index of. So let's take here. Chars count will give you number of elements in array. So 1, 2, 3, 4, 5, 6, 7. It will be 7. If we want to get this index, this is 0, 2, 3, 0, 1, 2, 3, 4, 5, 6. We need to get 6. So we can do chars count, which is 7, minus I, that is iterator, that goes from 0 to count, right? 0, 1, 2, 3, blah, blah, blah. And then we need to do minus 1, because that's a 0 base. We don't need 7, we need 6 here. So that will be our right index. Right? So now we get the char by right index. And that's it. We can compare if char equals, if left char equals right char, then all is good. We're moving forward to palindrome. But it's not guaranteeing us that the whole string is palindrome. If we see that this one equals to this one, that's unnecessary, but not enough, because there can be an error somewhere here in the middle. So we cannot do any consequences here. But if we see that they are not equal, then this is enough to say that this is not palindrome. We found at least one error, everything is not palindrome. So we return false here. Otherwise, if we go to the end and we still do not see any errors, we can easily return, we can, after for loop, right? We went through whole for loop and we still have not found any errors. We can say that it's false. Let's try it out. Print is palindrome for 1 to 1. X. For 1 to 3, for 3 to 1, 4 to 3, and for not palindrome. Okay, so enumerated. Chart, which Swift is this? Swift 4.0. I think it should be here. So chars is an array. Okay, how to deal with this if, let's say, like, I have no idea right now why it doesn't know enumerated. Maybe because it's a 4.40, or maybe I did some syntax mistake here. But it actually doesn't matter, because what you can do is always find some other approach. Like, enumerated doesn't want to work. Okay, let's use the regular thing in Swift, which is char in chars. That's basic for loop, right? So it will give me every single char in chars. And then we can say, let's declare some I, which is 0 by default. And then in the end of this, every time it will be I plus equal 1. Right? So will this be better? Oh my God. Import foundation. Array literal in call. So Oh, of course, string X was here. Nice. So we have some problems here, right? The problem is it shows us that 1-to-1 is not a palindrome. However, it is a palindrome. We know that this is a palindrome. So let's debug and find what is the actual error here. What is the actual error here? So how am I going to debug here? I'm going to leave one example, right? And I'm going to say, let's print out at least print out everything that we are looking for. Let's print left character, let's print right index, or left char and right characters, and see which character they think is different. So if I execute this, it will show me that it compares 1-to-1, 2-to-2, and 1-to-1. So why it is false? Oh, sure, because we return false in the end, right? If everything is fine and we have not found any errors, we need to return true. Let's try again. Okay, we found that's in a palindrome and that's not a palindrome. That's not palindrome as well, and this is not palindrome. Too many not palindromes example. Let's change one to actual palindrome. True. Okay, so this works. Now we're a little bit late on time, so let's move on to the second approach. What if interviewer asks you, that's a great solution, but what if we don't want to use string casting here? So please work with an integer, do not cast it to string. And I personally seen this being asked on the interview. So it's very common question. Because there is very important things in algorithm, which is efficiency. There are two important parameters here. What is your runtime consumption and memory consumption? Like how efficient, how fast your algorithm can work, and how little memory it uses. Unfortunately, we don't have time today to speak about how to count this. This is quite separate topic, but this is very important. Every single algorithm can be measured and can be it's good only if it's efficient, because you can solve anything with just brute force. You can try every possible case and solve the solution, but that's not efficient. So you always try to be more efficient. What if we want to work with integer only? Then we're going to use math principles here. So is palindrome with is palindrome no string? I'll say this. X int, same input, same output, right? It's bool. And we need to treat it as an X, as an integer. We cannot move to string. So what's the model here? We have some number, 1, 2, 3 to 1. Let's try to construct the reverse number with math. So let's try to byte digit by digit and construct the reverse number and then compare two numbers. So if we know how to get the last digit, then we'll be able to say that, well, let's construct 1. After that, we'll construct 1 and 2. After that, we'll construct 1 to 3. After that, we'll construct 1. I mean, we go from back 1, then 2, then 3, then we'll get 1, 2, 3, 2, and then we'll get 1, 2, 3, 2, 1, and then we'll compare. If the reversed number, construct reverse number, and we'll compare if the reverse number equals to original number. we can do that. So let's make a copy of the original number because we'll modify it. So let's equals x, let's do whatever, xx, right? We'll just use it as an original number that is modified, and it's just equal x. It's important to make it var because in Swift this is immutable. So now we need to create some reverse numbers. So we'll start from reverse number. We'll start from 0, and then we'll construct it with some mass. So we'll do this in some loop until we have anything to construct. So we'll figure out what's the condition later. Let's start from while loop, and we'll figure out the condition a little bit later. So what are math operations here? You probably know that if we divide 1 to 3 to 1, if we say modular division by 10, this is always the last digit, right? It's 1. Because if we divide 101 by 10, the remainder is 1. It's always the last digit. That's just how numbers and math works. So we can say that let's get a reminder as our xx modular divided by 10. And now we need somehow construct the resolved number. So the resolved number, reversed number. So we got reminder, so this is 1. We can just add it, right? For now, we can say it's the one that was, which is 0 by default, plus reminder. Let's start from this. And then our xx, we need to destroy this number. So we don't want to, we worked with the digit 1 already, so let's just destroy it. We can divide by 10 and it will be destroyed, right? So reverse now, xx equals xx by 10. This is whole number division. So if it was 1 to 3 to 1 divided by 10, it will be without one digit. And then we'll do again with this digit, right? So now on the next loop, our reverse number is 1. Our reverse number is 1. So our new reminder is 2, right? Is 2. So now we have 1 and we need to get 12. How to get from 1 to 12? We need to multiply 1 by 10, what we have now by 10, and add 2. Then if we have 12, we multiply it by 10, we got 120, and add 3. When we have 1 to 3, we multiply it by 10, we get 1,230, and add 2. That's how it works. So we missed here time step. And now, in the end, after while loop, if our original number equals reverse number, then it's true, it's palindrome. Now, what's the condition here? How long do we need to do this? Obviously, while we have what to destroy. So while our x is greater than 0, we have something to destroy, we can iterate. Let's check it out. Sorry, let me, is palindrome problem, is palindrome no string problem. Okay, true, false, that's correct. So any problem can be approached totally differently. Efficiency is not very different here, by the way. The memory storage is different. So anyway, this is better, but we're not going to dive into deep details how to count that efficiency today. What do I have more? So how to practice? First of all, if you don't know basic programming concept, then you need to some basic tutorials. You can do it in YouTube, for example, for Swift, just because I showed in this with, like, there is this famous guy, Chris, coding with Chris. They tell you those basic prerequisites very good. We have the prerequisites in our bootcamp. We'll talk about this later. The algorithm itself, the best one is lead code. It's pretty powerful. When I used to start coding challenges, there were 700 problems here. Now it's 200 something. So it's free, and they run thousands of tests to verify you. So it's a very good thing. And those problems here are from actual real interviews. So people submit problems here after interviews. This is very good database of interview questions. And obviously, if you want to learn in details from academic perspective, it's better to take some Coursera or something like that course. That's more academic. The most famous one is from Princeton, algorithms. I did this course 10 years ago, maybe, so it's pretty old, but it's very, like, algorithms do not change. They're there. They are known, and nothing new is invented. So those algorithms are same topics, same solutions. Once in decade, somebody finds more efficient solution for something, but the ideas are similar. So we have our bootcamp. That's iOS test automation. We do not cover algorithms there. It's more for automation, but we do have very good basic tutorials. First of all, I'm instructor there, so I tell it, and we discuss the most basic and important fundamental concepts of programming, of Swift, of debugging, of everything, data structures, and then we go hands-on to automation. So based on the real app, we automate a lot of interesting test scenarios there, and use and leverage a lot of techniques that are very in demand today in the market. So after this bootcamp, it's definitely possible to go for a real as the job. And again, a lot of people here in participants did this bootcamp with us offline back in the days in San Francisco before COVID. It used to be around 3,000. So now it's online. Maybe we'll get back to offline one day, but as of today, feel free to find this bootcamp on Udemy right now. So we'll share this link after the webinar, but obviously there is a special offer. You will be able to find this offer in the email after this webinar. So that's it. Let's see if we have any questions. I'll be happy to answer. So again, these coding challenges are a very sensitive topic, because basically, I'm pretty sure for some people here, it was like very simple and very easy problems we discuss here. But for some people here, for sure, it was some rocket science, because either they did not know prerequisites or they just didn't practice like ever. But again, this is all about practice. And once you practice those algorithms, they all look similar. So let's see if we have any questions. Feel free, you have chat, you have Q&A here in Zoom, so feel free. Any tips and advice on how to break into tech? Thank you. So that's exactly why we told about the bootcamp. So we will send you more info, but we think personally, and a lot of our students and graduates can like validate this hypothesis, that this bootcamp is very good bridge to tech. After this bootcamp, some people go to SDATs right away. Some people go to even development path and just change and start learning about development more, because we hands-on code there a lot in this bootcamp. So our advice obviously will be try our course, and we have a live team supporting you, so you'll be part of our community. You'll be able to ask any questions in our Slack channel, etc., etc. So yeah, the answer is bootcamps and learning and practice, obviously. Any other questions? Are you planning to add online course for Android? Yes, we plan to add online course to Android eventually. However, it will not happen fast, because this is a lot of effort here to do this bootcamp. It requires a lot of time, a lot of people that maintain this, and etc., etc. So we've just done with iOS. As of now, the iOS is live out there. Feel free to check it out. Android coming, but I will not be able to say it's coming very soon. Thank you for great explanation. Thank you, my pleasure. So again, I try my best to explain in details and in the most efficient way, like in the easiest way. Unfortunately, there are a lot of bootcamps there out in the web where people just assume that audience understands them, and it's not the case, right? So thank you. We're trying to explain in details. Any other questions? Okay, I don't see any questions. So thank you. Please subscribe to our social media, to our channels. Feel free to visit our website, Engenious.io. We do a lot of consulting, right? We have big companies that we help with automation and with development, like Apple, like Grammarly, and we have a lot of startups. So feel free to refer us as a consulting service. We have best experts on team, and obviously we do a revenue share, and we do referral bonuses. So if you ever need any development, automation, QA help, and consulting, feel free to reach me personally or Igor or info@engenious.io, and let's be in touch.